This shows the classifications of 50 skin lesions by two dermatologists, Dr. A and Dr. B. Each dermatologist assigned either 0, benign, or 1, malignant, to each lesion. I'll use these classifications to calculate Cohen's kappa. Pretty straightforward, right? This is a list showing Dr. A's classification for each of the 50 skin lesions. A 0 means Dr. A classified the lesion as benign, and a 1 means malignant. Similarly, this is the list of Dr. B's classifications for the same 50 skin lesions. I will compare these to Dr. A's to see how well they agree. I'll use the cohenkappascore function from the Sklearnmetric's library. This will let me quantitatively measure the agreement between Dr. A and Dr. B's classifications, while adjusting for the possibility of random agreement. Exciting, huh? This is a version of Cohen's kappa that treats all disagreements equally. It's a simple measure of agreement. This version of Cohen's kappa gives more weight to larger disagreements. For example, it penalizes classifying a malignant lesion as benign more heavily than classifying two benign lesions differently. This is useful because some disagreements are more consequential than others. I'm going to compare the unweighted and weighted kappa scores and use them to answer multiple-choice questions about the level of agreement between Dr. A and Dr. B's classifications. I need to determine whether the unweighted kappa score will be greater than the weighted kappa score. I'll check if the weighted kappa score is greater than or equal to 0.6. If so, I'll consider the agreement between Dr. A and Dr. B to be substantial. I'll determine whether Cohen's kappa is influenced by the overall proportions of benign and malignant classifications. This is a fundamental property of kappa. I'll determine if a perfect agreement, where both doctors classify all lesions identically, results in a kappa score of 1.0. This is a key property of Cohen's kappa. I'm using Cohen's kappa to assess the level of agreement between two dermatologists' classifications of skin lesions. Cohen's kappa is a statistical measure specifically designed to assess inter-rater reliability. How well two raters, in this case, dermatologists, agree on a set of classifications. It corrects for chance agreement, making it a more robust metric than simple percentage agreement. This is the question I'm asking you to answer. I'm presenting 4 statements about Cohen's kappa, a statistical measure of inter-rater agreement. Your task is to identify which statements are true. Let's see how well you understand Cohen's kappa. This is the core question. I want you to determine which of the following statements accurately reflect the properties and interpretation of Cohen's kappa. Let's dive into the statements and see if we can figure out the right ones. This statement compares two versions of Cohen's kappa. The unweighted version treats all disagreements equally. The weighted version considers the magnitude of the disagreement. For example, if one dermatologist says, benign, and the other says, malignant, that's a bigger disagreement than if both say, benign, but one is slightly less certain than the other. The weighted kappa will usually be lower because it's more strict. This statement focuses on the interpretation of the weighted kappa score. A score of 0.6 or higher is often considered substantial agreement. I'll need to calculate the weighted kappa to check if this statement is correct. This statement highlights a key property of Cohen's kappa, its sensitivity to the overall distribution of classifications. This means that the prevalence of benign versus malignant classifications will influence the kappa score. This is a fundamental concept that I need to keep in mind. This statement deals with the maximum value of Cohen's kappa. A perfect score of 1.0 would imply both dermatologists made identical classifications for all lesions. This is a straightforward and always true statement. I calculate the unweighted Cohen's kappa score. This measures the agreement between Dr. A and Dr. B, ignoring the severity of disagreements. A higher score means better agreement. I compare the unweighted and weighted kappa scores to see how they differ and interpret their meanings in relation to the level of agreement between Dr. A and Dr. B. Remember, a weighted kappa considers the magnitude of the disagreements. Here, I use the Cohen_kappa_score function from the Sklearn metrics library to compute two types of Cohen's kappa, one unweighted and one weighted, using the quadratic weight. I calculate the weighted kappa score. This considers how serious the disagreements are. Disagreements between a benign, 0, and malignant, 1, diagnosis receive a greater penalty than two similar diagnoses, both 0 or both 1. The quadratic weighting means the penalty increases with the square of the difference. This is the context 50 skin lesions are classified by two dermatologists, Dr. A and Dr. B, to provide the data for calculating Cohen's kappa. This line shows how Dr. A classified the 50 skin lesions, 0 for benign, 1 for malignant. This row presents Dr. B's classifications of the same 50 skin lesions, also using 0 for benign and 1 for malignant. I check if the unweighted kappa is greater than the weighted kappa. The weighted kappa usually is lower because it penalizes larger disagreements more heavily. I check whether the weighted kappa score meets or exceeds 0.6, the threshold for substantial agreement. This is a true, false statement. Cohen's kappa is indeed influenced by the overall proportions of benign and malignant classifications by each dermatologist. This is a true, false statement. A perfect match between the two dermatologists' classifications yields a kappa of 1.0, indicating perfect inter-rater reliability. I'm using Cohen's kappa to measure the level of agreement between two dermatologists in their classifications of skin lesions. I calculate this by using the Cohen_kappa_score function from Sklearn metrics without specifying any weights. This gives me a measure of agreement between Dr. A and Dr. B, but it treats all disagreements equally. It doesn't consider the magnitude of the disagreement. For example, it penalizes a disagreement between benign and malignant, the same as a disagreement between two benign classifications, even though these disagreements reflect different levels of error. Think of it like this: you're grading assignments, and you and your colleague disagree on a few. The unweighted kappa just counts the disagreements. It doesn't consider whether it's a small or big difference in the grades. This time, I use the same function but add weights equals quadratic . This tells the function to weigh disagreements differently. Specifically, a quadratic weighting scheme assigns higher penalties to larger disagreements. So, a disagreement between a benign and malignant classification is penalized more heavily than a disagreement between two benign predictions. Back to the grading example. This time, a larger discrepancy in grades receives a heavier penalty in the calculation of agreement. I compare the unweighted and weighted kappa scores. Based on these values, I determine which statements about the dermatologist's agreement are true. Remember, a higher kappa score indicates better agreement, and a perfect score is 1.0. I'll also check whether the weighted kappa meets the threshold for substantial agreement, which is usually defined as a value greater than or equal to 0.6. I'm essentially putting the kappa scores under a microscope to understand the level of agreement between our dermatologists. This row simply introduces the data we'll use: two dermatologists' classifications of 50 skin lesions. Each lesion is labeled as either benign, 0, or malignant, 1. I will use this data to assess how well the two doctors agree on their diagnoses. Here, I'm setting up to use Cohen's kappa, a statistical measure. It helps me figure out the level of agreement between Dr. A and Dr. B, while accounting for the possibility that some agreement might just be by chance. This is one way to calculate Cohen's kappa. It treats all disagreements equally, regardless of how different the classifications are. This is a different way to calculate Cohen's kappa. This version gives more importance to bigger disagreements. For example, classifying a malignant lesion as benign is considered a bigger mistake than classifying a benign lesion as benign. The quadratic part means the weight of disagreement increases by the square of the difference between classifications. After calculating the kappa values, both weighted and unweighted, I'll interpret the results to see how much agreement there actually is between the two dermatologists. I will test to see if the unweighted kappa is higher than the weighted kappa. Because the weighted kappa gives more importance to larger disagreements, it will usually be lower than or equal to the unweighted kappa. I will determine if the weighted kappa is greater than or equal to 0.6, which means the dermatologist's agreement would be considered substantial. This statement is always true. The marginal distributions, how often each dermatologist classified a lesion as benign or malignant, influence Cohen's kappa score. This is always true. A Cohen's kappa score of 1.0 means perfect agreement. That is, both dermatologists always classify the skin lesions exactly the same way. I have two dermatologists, Dr. A and Dr. B, who each classified 50 skin lesions as either benign, 0, or malignant, 1. I'll use their classifications to see how well they agree. Each dermatologist's classifications are presented as a list of zeros and ones. I'll calculate Cohen's kappa, a statistical measure that assesses the agreement between two raters, taking into account the possibility of agreement by chance. It's a great way to determine how well Dr. A and Dr. B agree. This is a basic Cohen's kappa calculation. It treats all disagreements equally, whether it's a small or large difference between the diagnoses, like benign versus malignant. This calculation is similar, but it gives more weight to larger disagreements. A disagreement between benign and malignant is considered more significant than a disagreement between two benign classifications. The quadratic weighting scheme assigns more weight to stronger disagreements. I'll interpret the kappa values. A higher kappa value indicates better agreement. I'll examine the values to find out whether the weighted kappa is higher or lower than the unweighted one, and whether it reaches the substantial agreement threshold 0.6 or higher. It's detective work with numbers. This shows Dr. A's classification of the 50 skin lesions. A 0 represents a benign classification and a 1 represents a malignant classification. This shows Dr. B's classification of the same 50 skin lesions. Again, 0 is benign and 1 is malignant. Notice that there are differences between Dr. A's and Dr. B's classifications for some lesions. These are the questions I will answer after calculating Cohen's kappa in both its unweighted and weighted forms. I'll compare the results to determine which statements are true. Cohen's kappa is a measure that tells us how much agreement there is between two raters, here, Dr. A and Dr. B, adjusting for the possibility of agreement occurring purely by chance. I'm analyzing how well two dermatologists agree on classifying skin lesions. I'll use a statistical measure called Cohen's kappa to quantify their agreement, considering both the unweighted and weighted versions. This will help me understand the level of consistency between their diagnoses. We're working with a dataset of 50 skin lesions. Each lesion was independently classified by Dr. A and Dr. B as either benign, 0, or malignant, 1. I need to compare these classifications to evaluate the level of agreement between them. This shows Dr. A's classification for each lesion. It's a list of zeros and ones, representing benign and malignant diagnoses respectively. I'll be using this data for my analysis. This is the corresponding list of Dr. B's classifications for the same 50 skin lesions. Again, 0 represents benign, and 1 represents malignant. I will be comparing this list with Dr. A's list. This is the actual list of Dr. A's classifications for the 50 skin lesions. This numerical data will be used to calculate Cohen's kappa. This is the actual list of Dr. B's classifications for the 50 skin lesions. This data will be compared to Dr. A's classifications in the calculation. I'm going to calculate Cohen's kappa. It's a statistical method to measure inter-rater agreement, correcting for agreement that might occur by chance. I'll calculate both the unweighted and the weighted versions. This is a basic calculation of Cohen's kappa. It treats all disagreements equally, regardless of how different the classifications are. I will compare this value with the weighted kappa value. This version of Cohen's kappa gives more weight to disagreements that are further apart. For example, classifying a lesion as malignant when it's actually benign gets a heavier penalty than misclassifying benign as benign. I will compare this value with the unweighted kappa value. I will check if the unweighted kappa is larger than the weighted kappa. The weighted version usually gives a lower score because it's more strict about disagreements. I need to see if the weighted kappa value is greater than or equal to 0.6. If it is, it means there is substantial agreement between the dermatologists. This statement is true. The marginal distributions, how many zeros and ones each dermatologist gave individually, influence the kappa score. This is a true statement. A score of 1.0 means the dermatologists classified every lesion identically, exhibiting perfect agreement.